So I'm Phil Zito. I'm the CEO of Building Automation Monthly. Glad to have you here today. We are going to be going through BAS Design Submittal Creation. And what I would like you to learn from this, what I'm hoping you take out of this is one, the importance of an accurate design, how designs are created, the actual process of creating a design, the outputs of a design, and then we're going to go over an actual design. And I'll talk through tips and tricks. You know, I see a lot of folks who natural progression is they start off as a technician, then they start doing design submittals for small jobs, then they work themselves into typically like a programmer role. And a lot of folks seem to get stuck on this design phase. They struggle with, making that progression from technician to designer. And I also see that a lot lately, a lot of consulting engineering firms are asking, hey, how do we do better designs? What would make it easier for the controls folks in order to have them accurately implement our design? So that's what we're going to cover here. My name, as I mentioned, is Phil Zito. I've been in this trade for a long time. Some of you know me, some of you don't. I've got a background in system integration, design, sales, project management, ops, done a little bit of everything. Worked with almost every system out there on the market. So today, like I said, we're going to go through the importance of design. We're going to go through a couple PowerPoints. I don't really have a lot of text on my PowerPoints. I tend to talk to them. And then after that, we are going to go and look at some design documents, and then we're going to look at a submittal. If you have any questions, just type them into the question box, and we'll get to them either at the end or we'll get to them if it's a question that's related to what we're covering. We'll cover it right then. All right, so what is a BAS design, right? So really, with a BAS design, it is a set of documents, essentially, that is going to guide the implementation of a building automation system in order to meet the design engineer or the owner's intent. I mean, at the end of the day, that's what it is, right? And it consists of a scope, some instructions, and some details. If you've ever been involved in building a house or building Legos or anything like that, you know that you can kind of eyeball things and start building, or you can actually have a set of instructions and build it. And usually it's a lot easier when you have a set of instructions. That is what a design submittal is. So as I mentioned, the design submittal consists of scope, instruction, and details where necessary. So scope is really important. It is going to be the primary thing I'm going to tell you to focus on whenever you're creating a submittal. If you don't focus on the scope, and when I say scope, I don't only mean the scope of the actual submittal, I also mean the scope of what's expected as part of creating the submittal. So as we scroll down here in the specification and we look at the submittals in the general conditions, and it tells us what the submittal's format should be, what documents it should cover, when it should be submitted. This is all scope of a submittal. And one of the biggest reasons I see submittals get rejected is failure to follow this right here. You should almost never have your submittals rejected because you used the wrong size paper or you did not include a specific detail sheet that was required by the submittals. But yet I've seen it happen time and time and time again. So the primary area of scope is one, the actual scope of the project, but two, the scope of the submittal submission. And this is where I see a lot of beginners who are creating submittals start to miss out. Now, obviously, some specs are not going to detail this out or just not detail it out clearly enough. We'll talk about some tools you can use later on in this webinar that will help you to really get this information and get clear on this. All right, so back to the PowerPoint. Also, we need instructions, right? So the scope is going to tell us, hey, this is what's going on, this is what is expected to be done, and this is how it needs to be submitted. Instructions are essentially how we execute that scope, and the instructions typically are our submittals. They're going to instruct a variety of players on our projects. They're going to instruct, so if we look at the submittals here, right? They're going to instruct just the average person who's looking at this submittal and is out in the field and is trying to understand what's what. They're going to instruct our electricians. How do they go and wire things up? They're going to instruct maybe a network person on what subnet addresses we need. It's instructions and guidelines for us to be able to go and properly implement a project. And finally, details. So there's going to be things that you're going to have to detail out. You know, if a common example is 24-volt transformers. So oftentimes we'll use 24-volt transformer circuit to power controllers, and then we'll have a separate circuit to power our I/O. However, if you don't go and detail this out, your electrician's just going to execute whatever they think is best if they don't clarify, which half the time they're so busy they may not clarify. So we really want to get our details accurate. So how do we do all this, right? Well, we have to first ingest information. We have to take information in order for us to be able to go and effectively execute a design. The key information we're going to take in are going to be mechanical, electrical, and plumbing plans, also known as MEP drawings, specifications, and scope of work documents. I'm not really going to cover existing documents, customer interviews, and site walks. That's more for retrofit projects. So if we think about these documents, right, the first one that we are primarily going to focus on is going to be the MEP set. Now, I know this kind of flies in the face of a lot of what folks have been taught, which is first focus on the spec. But I personally like to look at the mechanical drawings first, so I could just get an overview of what I'm dealing with. If I'm sitting down with my electrician to lay out, a network diagram, I'm going to start understanding where are my boxes. I'm going to start understanding where are my sensors. I'm going to start understanding where are potential additional controllers. So I can start to figure all this out. I can just get a feel of what I'm looking at. From there, I'm going to look at a scope of work document, what was actually sold, and then I'm going to move through a specification. So I'm going to talk through at a very high level mechanical drawings real quickly. I'm not going to assume you all know mechanical drawings. So if this is something you already know, don't worry, it'll be over in about 30 seconds. So mechanical drawing consists of a floor plan, and the floor plan is going to have details. And these details or notes are stuff you need to know because it will call out things like, hey, the location of the DDC panel should be mounted here, and you should coordinate with this person. It's also going to go and have our equipment schedule. And our equipment schedule is going to tell us what equipment we're actually controlling. And we can figure out real quickly how we're controlling it by reading the equipment schedule. And then finally, some mechanical drawings will actually have one lines of the systems. I mean, this is a very nice drawing in that it actually includes the I/O type, it includes all of the points, and it has the sequence of operations. So this is a good example. Not all are going to be like this. I would say a large portion of these, especially in the plan and spec market, are not going to be like this. From here, right, from there, the mechanical drawings, we move on to our scope of work, which I'm not really going to go through. And we also look at our specification. Now, specifications are structured according to three kind of structures, right? You're going to have part one, which is going to be general. You're going to have part two, which is going to be materials, products. And then part three is going to be execution. You need to understand all of these because part one is going to say, hey, what other specs do we need to be focused on? What do we need to integrate? What do we need to do for submittals? How are we going to validate the installation? Then, and I know I'm flying around here, but let me get to this right here. So part two is going to talk about the actual devices that we're going to utilize. And this is going to kind of say, hey, these are the devices you're going to use. These are the different types of sensors you're going to use, et cetera, et cetera. And then part three, which we'll scroll down to here, let's get down here, is going to talk about actual execution. How should COM trunk be run? How should sensors be installed? How should everything be tested and validated? All of this. So it's very important that you understand the spec because the spec is going to influence your actual design right here. Now, every design has a life cycle. And it's when I started to understand the life cycle of design that this all kind of really became much easier. Because if you approach a design submittal without understanding that it has a life cycle and you don't follow a process, you're just going to be putting documents together and there's going to be no rhyme or reason, and you're going to do a lot of duplication of effort. So let's talk through this. The design life cycle can really be broken out into 4 phases. I'm going to go a little slower here so you can take notes. Granted, this is going to be recorded. You're going to get a recording. But anyways, so there's 4 phases, right? Initiating, creating, modifying, and closing. I see most folks really get stuck at the closing phase, and we'll talk why a little bit later. But also just knowing that there's an initiating phase is going to really make your life a lot easier. So the initiating phase first begins with a start, and your start point is typically, for most of you listening to this, is going to be a new construction project. There are retro projects, retro commissioning, design validation, etc., but we're going to focus on new construction. So new construction, what's going to happen is a project's going to hit the street. If we're talking plan and spec, you're going to get requested to bid. Salesperson's going to bid it. They win the job. They submit their scope of work when they win the job, when they submit their bid, right? And you book the job. Great, wonderful. Now the salesperson should be starting this initiating phase where you should be going through and doing a sales to operations handoff. This is where you as the designer get involved. So this is where you can use, like, hopefully most of you have this, a design or review or sales to ops check sheet, and you're going to go through, do we have the latest drawings? Do we have the latest addendums? Do we have the latest spec? Are there any conditions we need to be aware of? What's the timeline? All these questions you should be asking that are going to really frame how you do your design. So if you think about it, right, I'm going to draw a little bit here. I'm not the world's best artist, but in the initiating phase, we are creating a frame, right? We're framing our design. So we're going to frame it. We're going to know the time. We're going to know the scope. And we're going to know kind of any unknowns. We're going to start building a question list. Now, I had mentioned earlier that there are some vehicles that you can use in order to go and really make sure that you clarify things. Those are request for information and request for clarification. It's in this initiating phase that you're going to start to build out your list of request for information and request for clarification. So the simple way of knowing the two, request for information is information you don't have. Request for clarification is clarification of information you do have. So if someone said something crazy, and I've shown this, some of you who are in our design fundamentals course have seen this, but if an engineer did something like, hey, we're going to do 4 to 20 milliamp sensors for every sensor, and you're thinking to yourself, holy moly, that is, $100, $150 a sensor instead of $20 to $30 a sensor. Why would we do that? Oh, this is a school district too. Why would we, for a school, do 4 to 20 milliamp sensors with platinum RTD for every sensor? That does not make any sense whatsoever. And so you would go and seek a request for clarification. Like, why are we doing this? You may submit what's known as an alternate. All this stuff is happening during this initiating phase. Now, once you've got that initial draft of RFIs and RFCs submitted and kind of clarified, you start to move into the creation phase. This is where we start to create our design documents. And we're going to go through design documents in greater detail in just a little bit. And by the way, folks, if any of you have questions at any time, feel free to type them into the question box. I know how hard it can be to hold them into your head for the next 45 minutes. I may not answer them immediately, but feel free to submit them so they're in the queue. All right, as I said, you go into this creation phase, right? And this creation phase, you're reviewing your inputs. I'm going through my spec. I'm finding crazy things like this. I'm going through my my mechanical drawings, and I'm starting to see things like, oh my gosh, the sequence, for example, for this air handling unit right here is actually, if we went and looked at it in the spec, which I think it's like right here. If we start to look at this sequence of operations and we look at this sequence of operations, they don't match. So we start to do input reviews and we start to see that our inputs have conflicts. Or maybe we start to find out that we're working off old drawings. Or maybe we start to realize that our scope of work is not accurate. We start to filter through all these things. That's why input review is first before creation of design documents. It can be tempting, and I myself have been guilty of this, where I look at a drawing, right, and I see that it has right here, 25 reheat VAV boxes, actually SCR, not hot water reheat. And I could just start my drawings right away. I could be like, oh, I'm just going to do these things. I know what to do. But if you don't do the input review first, you may actually end up messing up. There may be things that, for example, you may not be responsible for the valves, the control valves. That may be the mechanical. And if you put those on your drawings and you submit it, and all of a sudden you haven't clarified to be installed by mechanical, you've created a big nightmare. These are kind of all the landmines that you got to watch out for. That's why it's so important to do an input review and to have a checklist to work off of. Then you start to create your design documents. Now it's at this point that you submit your submittals and you start to move into the modifying phase. So the modifying phase, right? And so I'm getting some of you who are saying the sound is dropping out. Are a lot of people getting that? Or is that just one or two? I mean, this is being recorded, so we should be good. Okay, I'm getting everyone else saying it sounds fine. So most likely it's a bandwidth issue on the people who are saying that. Okay, cool. Make sure you're not on Wi-Fi and you're on good solid network. All right, anyway, so let's continue. So the submittal process, and this is the fun part. I like the submittal process because here's the deal. A lot of people who are like, submittals are so freaking hard, they always get rejected, blah, 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 blah. The reason that crap happens is because they either do some stupid stuff where they're just, oh, it's supposed to be on 11 by 17, and they submit them on 24 by 36 because they're like, hey, this is how we've always done it, so we're going to do it this way. Or, they don't include the catalog sheets, even though it clearly says, hey, give me the product specification sheets. And they're like, no, I'm not going to do that. And then they get their submittals rejected and they're like, why? Or they don't do a input review. They don't get the latest addendums and then they miss an entire part of the building. Or they go and they rush through things and there's, not an accurate RFI RFC. I'm telling you from experience, if you do RFIs RFCs during the initiating phase, and if you go right here, right? So during your initiating phase, you're going to do your RFIs, RFCs, and scope review. Then in the creation phase, you do your input review and the creation of the documents. And then you submit, you're going to find your submittal rejections are going to go down substantially. And that's important because how many of you have time to just keep doing the same submittals again and again and again? Probably not. Probably not a lot of you. I mean, we are in a labor shortage. So if you're able to shorten this and reduce rejection rates, that's a positive. And quite honestly, if you're a design engineer and your boss isn't measuring your submittal rejection rate, they should be, because that's what I would measure my design engineers by. I'd say how many of your submittals get rejected. And if that's low, then that's obviously a success factor that we need to improve. So then we move into this RFI RFC process. This is really important because if you do RFIs and RFCs wrong, then what's going to happen is you're going to go and not get them answered, or you could actually just find your stuff going somewhere where it never gets even put into the contracting tier. Now, I know I talk about in the initiating phase and in the creating phase using RFIs and RFCs, but it's at this point when you do a submittal that you would actually do a formal RFI and RFC process. Like in the past, you were just submitting it. Now we're doing our submittal and we're going to sit down, and if anything gets red flagged, we're going to go through a formal process. And it's important here, whereas here in the initiating and creating phase, technically email is a legal document, so you can email someone and get their clarification. And what happens is that, okay, you go and you submit your clarification via email, and that's a legal document. But here, what I say by RFI and RFC process, and why I say really formalize it, is because if you go and you submit something and it does get rejected, you really need to be formal here. You need to have them red line or circle or whatever the issue, document the issue, and then you formally document your response to that issue. And then you get them, whoever it is, to clarify that that response was adequate. This is not something you want to do via email, where you could do that in the initiating and creating phase. Here in the modifying phase, it's got to be very formal. And you want to do this so that you can pin the person down to say, this is exactly what I expect. So often conflicts would be network layouts, IP addressing, conflicts between sequence of operations, as I showed you earlier. Those are all things we're going to pin down. Okay, so I think we have a question that relates to this. What's the best thing to do if the GC is not giving all the submittals? So you're talking about not giving all the drawings, is what I think you're saying, not giving all of the mechanical and specification, and not giving you the proper addendums. So if they're not giving you that, I mean, you can't create the submittals. So that is just something you would communicate during using the formal communication process, that if they are not providing you the mechanical drawings or the mechanical details, here's a really common one, right? You're under the mechanical. The mechanical decides that they are going to use packaged controls, like a packaged rooftop. Let's just say Train. I'm not picking on Train, but let's just say them, right? They're top of mind because they just went through some like rebranding. So they pick a Train unit, and the Train unit, you need to know what the sequence of operations that Train unit can do to make sure it's adherent to the spec. Now, granted, it should be the mechanical adhering to that because they went and decided to get the embedded controls, but you're the controls contractor and crap rolls downhill, so you want to be cognizant of that. So in this case, you're going to submit clarification, and you're going to make notice of a delay that without this document, without these documents, you cannot properly perform. So hopefully that makes sense. And I've got some other folks who say you can also copy the engineer of record when requesting their documents. I mean, technically, you would hope that the engineer of record would have those documents because they're creating an initial design, but on a lot of plan and spec work, that's just going to roll down to the mechanical. All right, so let's continue on. Moving on to the last PowerPoint, and then we'll go and we'll do some document review. All right, so the outputs of a BAS design. Oh, no, we're not done yet. Closing. Oh my gosh, even I started this whole little slide deck right here off by telling you all that closing is the part people mess up and miss all the time, and then I went and skipped it. I mean, that's how like it is. It's so insidious. So basically what happens is you want to get off the job. You want to make sure that you get off the job and you're not stuck there in project retainage hell for all of warranty for the rest of your life. So what you do is you do an accurate and adequate closing. And what that means is, okay, you've done your submittals. Your electrician has went out and executed the project. Your techs have executed the project. Everything's programmed. Now you want to make sure that you do a proper point-to-point checkout and functional test. You want to get these documents recorded, pull them into your as-builts. As-builts are as the project was built. And then you want to consolidate red lines and as-builts together into a single actual as-built submittal deck. And there's two reasons this is important. One is contractually, you're almost always required to provide this. But two is when you go into the warranty phase, and everyone knows, like, who's done a project, you go into warranty and you just hope no one calls you for a year. You're like, man, I just hope someone doesn't change the balancing set points and then it's our fault, or someone locks themselves out of the computer and it's our fault. I mean, it's always the controls person's fault. So what you're hoping is no one contacts you for a year. And how you do that when someone does end up contacting you, how you protect yourself is having an accurate as-built submittal deck. Because when you have an accurate as-built submittal deck, that is going to be the reference point for all challenges. So if something doesn't work, if something's not properly installed, if something's broke, blah, 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 and you have a accurate as-built submittal deck that accurately represents how things were installed, where they were installed, and then someone argues, oh, well, I didn't want that temperature sensor there, or, oh, that was supposed to be a humidity and temperature sensor, or, oh, that CO2 sensor was supposed to be on the wall instead of in the return air duct. But you've got an approved submittal deck, and you've got your as-builts, which are based on that approved submittal deck. You've got yourself more covered than if you didn't. I won't lie and tell you that you're completely covered. You know, when you are the controls contractor, you're a second or third tier contractor, depending on where you're at in the contract. So crap's going to roll downhill and your negotiating power tends to be low unless you're owner direct. But at least it's going to help you from a contractual standpoint that you did actually execute what you were supposed to do. And I guess I'd add a third reason. We really want our drawings to be good so that the end user who's actually going to be out using this stuff, who's oftentimes not involved in the project at all until owner training comes along, so that they actually know what was installed and they know who to contact rather than just going and manually breaking something. All right, so let's take a look. I'm going to pause, make sure, do we have any questions so far? If not, we are going to start looking through a submittal deck. I'm going to talk through kind of how created this. All right, cool. Not seeing any questions. So this is a submittal deck that we do as part of our Design for Building Automation Professionals online course. We have a course where we teach people to create submittals from scratch. And as part of this course, they have to use those documents I just showed you, right? The spec and the mechanical drawings to actually create the submittal deck or submittal set. So I'm going to go through what each one of these drawings are real quick at high level, and then I'm going to talk you through kind of how we went about creating these and the logic behind creating these. So let's dive in. And as always, if you have any questions, just feel free to type them in. I think this webinar is actually going to be on time. Most of our webinars run about 30 minutes too long. I think this one's actually going to be on time for once. Okay, so the title page, pretty straightforward, right? The whole purpose here is to just make sure that we know what project we're working on. Your big thing here is don't copy and paste, don't have a different project on it. For the love of Pete, just double check it. You don't want to have, you know, someone else's site address or someone else's project name on here. You just want to have the information that's needed, right? You're going to want to know what the name of the project is, where it's at, who designed it, who PM'd it, and what revision is this actual document. I mean, if this is revision 100, fine. Just have an actual revisioning system so we know what the latest drawings are. Ideally, you would have a date on here as well. The index page can be used for two things, right? It can be used to list out the pages that are in the actual submittal, and it can also be used, and we'll see this kind of here, can also be used to list out any detail, or no, actually, do they show this on here? They may not show this on here. No, they don't. They don't show that on here, do they? Kind of, not really. Oh, there we go. So it can also be to list out any symbols. My general rule of thumb, right, is that if anyone is looking at this document that you're creating, this submittal, and they cannot within, so if I gave someone this right here, and within 10 seconds, they couldn't like figure out that that's BACnet MSTP, then I would want to go and say, hey, you know, red is BACnet MSTP. Oh, blue is IP. And if they can't figure out that, hey, BACnet MSTP, we're going to be using 22.3 or 18.4 or whatever, then I'm going to list that out. Just so the information they need is information you're going to want to include. And you can put that on the index page if you want. I usually will if I'm using a lot of complexity. Network riser, this is super important. So I'm going to teach you some tricks here that are going to reduce your electrical cost, are going to make your comm trunks faster, and are going to just make your life generally easier. Now, it never fails that you will do a site walk with the electrician, and you're going to go and you're going to see, oh, this is classroom 1.311 or VAV A1-23. And you're going to say, okay, what you should not do, let me back up. What you should not do is base it on the actual room number. You should really not base anything on the room number, because room numbers almost always change. It never fails. So what I like to do with my electrician is I like to figure out kind of where's my supervisory device going to be? So where is it going to be? And if we actually start to dig into it, if I remember this correctly, it's in the telecom closet. It is, where was it? Provide the, it's up here actually, isn't it? It's somewhere on here. Provide the supervisory device box. So anyways, I'm not going to waste your time searching for it, but basically it ends up that it is somewhere in here, right? If I remember correctly, it's in the telecom closet, and you've got your supervisory device, which makes sense because your IP drops are going to be right there as well. And so what happens is you have your supervisory device, and then you figure out, okay, this is BACnet MSTP, which we know from our spec, right? We would read our products and we would figure out what we're using as far as control line. And then we would just go and run our comm trunk. We would sit there with our electrician for, about 30 minutes to an hour, depending on, or a couple hours, depending on the size of the job. And we'd say, oh, we're going to have a controller here. And then, by the way, it's going to go from here to here. And then we just bounce along. And what happens is we create a logical flow for our controllers. And then once we have that laid out, that's going to reduce our electrical cost, because our electricians are now not going all over the place, but they're going from controller to controller to controller. And then what we would do, and here's the key, right? You would do this initially where you would just lay these out. And then once this is actually done by the electrician, you would validate that this is the order they were wired in. And once that is done, and this is where folks are going to get a little conflicted, because there's two ways you can do this, right? You can address everything up front and then install it, or as I prefer to do, I prefer to have the electrician lay this out and then address everything afterwards as part of my, hey, I'm a technician, I'm touching every box, I'm touching every VAV controller. I personally like to do that because it saves a lot of time to poke your head up in the ceiling, touch the controller, make sure that your nuts are tightened, make sure that the floating actuator or proportional actuator is actually properly positioned, all that stuff. By doing a quick glance and then addressing in that order and then updating my drawings with an updated accurate address, it's going to cost you a little time up front, but it's going to save you much more time in the long run, because you are doing essentially a point-to-point validation. Now, the reason you want to address these sequentially with BACnet MSTP is how it communicates. It goes sequentially from address to address when it passes the token. So if you have like 4 and then 20 and then 2 and then 5, what's going to happen is it's going to have to go down to 2 and, well, actually to 4 and then to 5 over here. And it's really going to slow the network down. I also like to get up front with IT, get my IP addresses, and get everything kind of figured out, get my IP addresses up front, understand what they are, and get all that subnet and IP address goodness figured out prior to actually even installing anything. So if I know I'm going to have IP addresses, I'm going to submit. That's the first thing I'm going to submit up front. And from there, right, that's our network riser diagram. We move into a system drawing. Now the system drawing, I like to split it into 2 drawings. Some folks will do 1 drawing. Now with Visio, which I like to draw my submittals in Visio, you can actually quite easily, using an HVAC stencil, I don't know if I have that stencil in here, do I? Yeah, the HVAC controls stencil, you can just go and create actual one lines of your equipment pretty easily, create your diagrams pretty easily. And I like to go and have a name for the point, have the actual material, and then have a model number. And then that will be linked accordingly. And you can go into these documents or to these stencils and you can set them, hey, this is the duct probe. Does it have a limit? No. And you can do its tag and everything. So you can actually make these pretty accurate. And then what I like to do is any notes for the electrician. So for in this case, the supply fan command is wired through the normally closed side of the LTA, low temp alarm, and high static pressure. Upon alarm, supply fan circuit will be broken until manual reset. Okay. And what I like to do, as I mentioned, is I like to split right here. I like to split my one line document and then my SOP onto a separate page. So I like to have my SOP on a separate page. And the reason I like to have my SOP and points on this separate page is this is kind of my electrician, where do things go, what's my bill of material page. This is my commissioning agent functional test point-to-point check page. You could actually expand this even further and you could add your sensed value and actual value, and you could do your point-to-point right on the submittals. And in a final submittal deck, you could actually have all that right here. But I like to do this because then when I'm sitting with the commissioning agent or I'm sitting doing a functional test, I have everything right here at my fingertips. And I'm also getting the design engineer to approve this. They're approving my naming standard, they're approving my points, they're approving right here my sequence of operations. It's all getting approved by them as part of the submittal package. And then we have a controller diagram. And this is going to be very different than a lot of people's controller diagrams. A lot of folks like to go and put the actual wiring on the controller diagram. Personally, my desire, what I like to do, is I like to just call electrical details. I like to say, okay, input 1 and input 1 common is going to go to electrical detail 1. And then on the following page, I will have electrical detail 1. And I'll show, kind of how that works. Remember how we have different types of sensors. In this specific drawing, I'm just showing a bunch of different types. As I said, though, as part of this project, if we recall, they had the 4 to 20 milliamps. I don't have it up here. They had the 4 to 20 milliamps for everything, so we would be using most likely like EDI2 for everything. But what I do by doing that, by separating this, is I only have to change my wiring in one spot. I can build out this electrical details and I can have this, essentially, I can save a Visio file or a Autocad file with a bunch of electrical details. And then what happens is I can use these electrical details moving forward. So on every project I do, instead of going and having to draw out on each controller diagram, I just reference an electrical detail. And if I need to create a new electrical detail, then I just create one. And I build up this electrical detail library, and it makes it really quick for creating my submittals. So from there, right, we have our terminal units, pretty straightforward. And the big thing here is typical. If you are doing multiple different types of the same piece of equipment, so we have a VAV box with heating, we have a VAV box without heating, then we want to call that out as typical of X, C, what? Mechanical Schedule 4.02. And so we'll call that out, and then we have our points list right here. So pretty straightforward approach to submittals. So let me recap real quick, and then we'll open it up for question and answer for the next 20 minutes. So as I said, the submittals, right, they're part of a process. And that process consists of starting it off, right? We have a project, we initiate, and our initiation is going to actually be doing our sales to ops, reviewing our documents. Creating, we're going to do our formal document review. We're going to do our creation of our design documents. Modifying, we're going to submit, and then we're going to adjust based on any responses we get. And closing, we're going to close out our projects. Our design deliverables are typically going to be a title page, index, network riser, system drawing, point list, and controller drawing. Granted, remember that on a submittal, we will have, and let me scroll down to it, other requirements as part of the submittal. We will have things like maybe we need specification sheets, maybe we need a operations manual. All these documents may be required, and we need to be cognizant of that. And also, typically in the specification, they will also have our closeout document requirements as well. And we've got to pay attention to that because that can sometimes be different than our submittal document requirements. So with that being said, questions and answers. Either I was so clear that none of you have questions, which would be awesome, or you forgot how to type into the question box. So I'll remind y'all, because I've got several new names on here. Okay, I see David Villa has his hand raised. I can unmute you if you're in a quiet spot. That's no problem. So let me answer this question that came in before, and then I will get you. All right. So does this recording get emailed out automatically? Maybe. So it sometimes does. GoToWebinar is good for a lot of things. For whatever reason, sometimes it emails out the recording, sometimes it does not. The good news is we will always put these webinar recordings on our YouTube page as well as on our website under webinars, so you can see all of our past webinars. They are on our webpage. Okay, so David's hand went away, so I guess his question went away. All right, perfect. So for the rest of you, this is your time to ask any questions about any design related topics that you have. I would love to answer them for you. And Andrew, I will answer your question about our courses in just a little bit. Can I review commissioning and how it relates to submittals? Yeah, sure. So there is formal commissioning and then there's informal commissioning. So formal commissioning is actual where you have a commissioning agent. They're either working for the general contractor or they're working as an owner's agent, and they actually create a formal commissioning test plan. And this test plan will cover how they validate a system is actually functional. And they'll go through the test plan, and it's called a functional test. And they will validate documents, they'll validate design, they'll validate functional test according to their test plan. And if you pass it, great. If you don't, you have to mediate, or you have to, not mediate, you have to fix the issue, remediate, that's the word I was looking for. You have to remediate any of the delinquencies. Then there's informal commissioning, which is basically just glorified point-to-point, where you're going through and you're just doing a point-to-point check internally. So that's kind of the difference. Okay, someone asked when we'll be hosting the design course again. So all of our courses are online and they are self-paced. So if you purchase one of our courses, they're online, they're self-paced. And you can go through them at your own pace. We do not do live courses because I tend to find that folks learning live, where they only get to watch it once, they tend to forget what they learned. So our philosophy is have it recorded so you can watch it again and again and again. All right, do I primarily use Visio or do I use Autocad? I personally like Visio. I think Autocad is overkill. And personally, I think Autocad is much slower on the type of machines that most people have. I've got a pretty beefy machine that can actually, do Autocad like it's nothing, but a lot of folks don't. So I personally prefer Visio. A lot of people do Autocad as well. It just really depends. Can I propose an SOP to an engineer if it took so long to get back to us? You could. I would not ever propose a sequence of operations. So I remember I was on a high school and was working on a high school project. And what happened was one of the technicians, or not technicians, one of the designers was known for his packaged rooftop design. And so the packaged rooftop design was all they did. And so this 300,000 square foot high school, I mean, massive high school, really big. Things are big in Texas. Was covered in rooftops, or yeah, covered in packaged rooftop units. It was ridiculous. And so he had never done a central utility plant before. And I remember sitting in the meeting and him looking at me like, hey, what's the sequence of operations for the chiller plant? And I'm looking at him like, I don't know, you're the professional engineer. And so basically ended up from my boss telling me, you need to write the sequence of operations for the central plant because we have other jobs with this engineer and we got to make them look good. That way we can get the other jobs. But I mean, in an ideal scenario, if you are not a professional engineer, you do not want to be writing the sequence of operations because you have liability. Another thing that you need to be really cognizant of late is cybersecurity and who is liable for an insecure design. So if you're going and creating a design where you're using cable modems and giving everything a public IP address, and that's insecure, and something happens because of that, you could technically be liable for that design. So just be cognizant of that. Not to scare you, just be aware it exists. In design build projects, with only design intent, what is the best practice for creating documents and submittals? Using templates. So you should have templates that cover, the basic stuff. So, basic rooftop templates, basic air handler templates. There's only so many ways to control an air-cooled chiller, to control a water-cooled chiller, to control a rooftop unit, to control an air handler. So you should be building out a template library and you can piece those together real quick. So that's a good question. We didn't cover, SDs, DDs, and CDs. So schematic designs, your designs and then your construction designs, right? And so as you progress from schematics to construction designs, you are going from something that is, I want a building to I want, this building with this floor, with this room, with this type of wall. And depending on when you're engaged based on the contracting vehicle, whether it's design build or owner direct or et cetera, the level of detail in your submittals is going to be different. The level of details of submittals in an SD phase is going to be completely different than the level of detail in submittals in a CD phase. So just be cognizant of that. All right, you're welcome. When doing a complete replacement of existing controls, doing submittals from original documentation, what's the easiest way to convert original docs to editable docs? It depends on what they are. I mean, personally, I like, so there's a lot of software. You can import stuff into CAD. You can edit, so PDFs. You can edit stuff. You could like redline stuff, things like that. There's a variety of different things you could do. Most submittals are gonna be just scan them, mark them up, and then kind of take that marked up drawing and have someone reproduce it. That's kind of what I would do. I would not go off existing drawings. I would create my own, but you can see, right? I mean, I can start to kind of edit the layers here. So I wonder, see, kind of see how I'm doing that right here and just editing all the layers that are in here with my PDF. So. As a facility manager, when should one get involved in the BAS process? So that's a good question. Ideally, you would have a BAS standard, and that BAS standard would have standard sequences, would have standard point naming, would have standard drawings, would have standard graphics. Here's the thing. For every dollar or hour you put into creating a BAS standard, it's my experience that you're going to get $3 or 3 hours back. And here's what I mean. If you take the time, you take an hour to create graphic standards for your site, and now every time they create a home page or an air handler page, they're using a pre-created graphic for that air handler or for that home page, your cost of implementation has gone lower. If you use the same sequence for every rooftop unit or for every VAV box, then in theory, the controls contractor, if they're the same one or if the same brand at least, they should be able to take a common code base and real quickly implement code across your buildings. So if you have multiple buildings, you definitely should create a BAS standard. You should have standard code. You should have standard graphics. And you don't necessarily have to do this. You should just be asking for this at the end of projects and taking the graphics and taking the programs that you like the best and be using those as your standards that will be utilized going forward. All right. How often do I find that the EOR, engineer of record, doesn't know much about controls and uses boilerplate language, expecting the controls firm to fill in the blanks? Not so much as I used to. And it also depends on if it's plan and spec work and it's, light commercial, small projects, or if it's, a hospital. So on the larger projects, I find that, and especially on design build, things like that, I find that the people are more educated. On the other projects like plan and spec, small projects, I tend to find that they rely more on the controls contractor. However, in their defense, most of the time they're doing packaged controls and electromechanical thermostats. All right, I see some questions coming in through the chat. All right. Okay. One of the concerns I have is costing exercise completed by the sales engineer can sometimes go way off course once the design guy gets to the detail. Yeah, that can happen. That's why I recommend submittal libraries, and that's why I recommend points libraries and system libraries. That will really help reduce the drift between scoped cost and actual designed cost. Get our Visio template. We don't give out our Visio template except to students in the course. Sure, if you send me an email after this webinar, I will send you the link to our design course. Not a problem. All right, perfect. What other questions, folks? We've got about 7 more minutes. It looks like this webinar might actually finish on time. It's amazing. Most of ours, like I said, go about half an hour longer. By the way, please do complete the post webinar survey that should pop up as soon as you finish. That would be really helpful. It just gives us feedback on what to cover going forward, and it also gives us an idea where we can improve moving forward. So what other questions are in y'all's head? Feel free to ask. How to do a point-to-point check. Okay. So, I mean, there's much more detail than I can show you with a screen share, but essentially what you do is you have a points list and you go and you use your meter and you walk up to the sensor and you meter it if it's resistive or if it's voltage, or maybe you've got a temp probe, and you check the sensed value on your sensor, on your multimeter, etc., and then the actual value you're seeing there in the field. So sensed value on the controller, front end, whatever, and then the actual value you're seeing on your meter or thermometer. And that is how you do a basic point-to-point check. No worries, Jeff. There will be a recording. All right. Do I recommend having the BAS on a virtual machine? I mean, almost always, because virtual machines provide so many opportunities for failover. I think a lot of folks, when they hear virtual machine, they get it mixed up with virtual machine and cloud and data center. So I can run a virtual machine on my computer right here. I can go and run a virtual machine. You do not have to have your BAS server in the data center. You do not have to have it in the cloud. You can run a virtual machine right on Windows desktop. So I almost always recommend virtual machines, because what that allows you to do is you create a snapshot of the BAS install, so that if it fails, what will happen is that you can bring that up right away. You can bring it back up. So that's why I recommend having a virtual machine. So someone said, if you have a virtual machine, you may lose routed alarms if it's not on. Yeah, that's true, but the bigger issue is that your virtual machine's not on. So not that you're losing alarms. Seems the name of the game is to document everything and that the devil is in the details. Is there any place where ambiguity or field level decision is acceptable? Of course, yeah. I mean, you don't have to document everything down to like a gnat's butt, right? The thing is just using common sense. I mean, if you've got 400 valves and it's potential that the mechanical is supposed to be providing and installing them, that's probably something you want to clarify. But if you've got 2 temperature sensors and you're not 100% sure of where they should be installed, it's okay to field verify that. When I look at details, I look at mass and impact. So if there's going to be a massive amount of something, I want to verify that that's accurate. Who's installing it? What part number is it? Etc. But if it's something that is like, minor, couple things here or there, a graphic, stuff that can be easily fixed, then I'm not going to spend a whole ton of time going through an RFI process on that. What would you suggest to identify design changes based on third-party supplied equipment? The result will be the same essentially, but maybe the consultant is expecting X and we will design Y because of the supplied equipment. So that's why I recommend that you review those documents from the mechanical, from whoever's providing that packaged equipment beforehand. You review their points list, you review the information, and then from there you go and you either RFI it or you have a team meeting. There's so many different strategies you can implement. The important point is just getting ahead of it and being aware of any issues that may come up. All right. So looks like we have just a couple minutes left. Take 1 or 2 more questions. All right, last call. Going once. Going twice. All right. So good stuff. I hope you all enjoyed this. We actually were on time for once. That's pretty awesome. And that being said, if you have any questions after the fact, just feel free to reach out. This will be on YouTube. This will also be on our website. I encourage you to fill out the post-webinar survey. Give us your feedback. That would be super helpful. So thanks a ton for attending. I appreciate you all being here, and I hope you all have a great rest of your day and great rest of your week. Take care.